Hello and welcome back to part two. We left off with World IP version 6 launch day, something you can celebrate in the years to come. I want to talk about some more differences with IP version 6. So remember in version 4, we said there were three parts. There's a network part, a subnet part, and a host part. In IPv6, you also have three parts, but they're different names. There's a routing prefix, a subnet ID, and an interface ID. So here, those three pieces have to total up to 32 bits. Here, they can total up to 128 bits. Now, the interface ID they reserve 64 bits for the interface ID, which is in fact your MAC address. Now, don't get confused or don't get weirded out because, yes, we said a MAC address is 48 bits, so where are the extra bits? Well, yes, there's some extra bits in there that are being used or being repurposed for other purposes, but basically the first half of the address is just a MAC address, and that's what keeps them unique, which is a clever way of doing it. So obviously, how many bits do you have for the routing prefix and the subnet ID combined? Well, 64. 128 minus 64 is 64. However, you can choose how much you're going to use for what we used to call the network part and what we used to call the subnet part. So just a little terminology, but the idea is still the same. I get a lot of good information from techrepublic.com. I don't know if this is a web page you keep up with, but if you're getting into networking, this has it has some crap out there too, but there is some good stuff as well. So there's a good list out here of 10 things you should know about IPv6 that uses hexadecimal. The link local unicast address is easy to figure out. We talked about leading zeros in class that are suppressed and just the notation. Inline zeros can sometimes be suppressed depending on where they are. There's some good info in here to check out. Also, Tech Republic a lot of times reprints Gartner reports for free. So I've talked about how important Gartner is as an authoritative source of information. Tech Republic frequently reprints their articles, so just bookmark it for future reference. And some other weirdness with IPv6, there are two modes for configuring IP addresses. So in version 4, you can either do DHCP or you can hard code a static address. In version 6, there are two ways to do it. One is with DHCP, it's just called version 6, but it works the same way as DHCP that we've talked about in class. It just automatically hands out IP addresses out of its scope of addresses, its range of addresses. But the second one is the new, funky, weird one, and this is stateless auto configuration. It does not need a DHCP server. Let's pause for that to sink in. Imagine a client that is configuring itself without the use of a server. You can't do this in version 4, but in version 6, this is interesting. So without the help of a server, it configures itself. So it creates its link local IP address, that first 64-bit address based off of its MAC address because it knows what its own MAC address is. And then it creates a global unicast IPv6 address for the second half of the address. And the way and in fact, if all you're doing is passing traffic on a local area network, on a LAN, all you need is that link local address. But if you're going out over the internet, you need to configure the rest of the address, that second half of the address. And the way it does that is with this new protocol, ICMP version 6, neighbor discovery. So it figures out what addresses are being used, what IP addresses are being used on the network at that point, and what's available to be used, and it configures itself with an unused address. That's weird to me, but apparently it works. And it communicates that with the router to let it know what address it's using. Yeah, just some more detail on stateless auto configuration. I just want you to be aware that there is such a thing as v6 stateless auto configuration. We said DHCP works in a very similar way. DNS works in a very similar way. But of course, the records are now longer. Since you've got longer IP addresses, the address space for the address name has to be longer. In fact, it's going to be 4 times as long. So in DNS, you've got it's just called an A record. It's the most basic record that contains the IP address and the name for doing the name resolution lookup. That's called an A record in version 4. In version 6, since it's 4 times as long, it's called an AAAA record. Sorry, I just ignored my wife there because she was calling me on the cell phone. I really need to come up with a more professional setup for doing these videos. But it's okay, because you know what? I don't care. You're going to watch it once and then throw it away. It's not like this is a revenue-making opportunity for me or anything. So, oh my gosh, she's calling me back. And so I'm just going to put it on vibrate. There. I know this has got to be entertaining for you. So anyway, it's called an AAAA record. Some people call it a quad A or an A4 record, but it's just 4 A's because it's 4 times as long. That's how you know you're dealing with a version 6 DNS record. Because of the beauty of how the Neighborhood Discovery Protocol works, you don't need ARP anymore. Makes me kind of sad. I love ARP. ARP is a very useful protocol, but you can see how you just don't need it anymore in version 6. So that's, to me, kind of a fundamental change in the V6 environment. So I just want to wrap up with a couple of ideas for you, namely how to trouble, you've learned a lot about networking so far, but how do you troubleshoot network problems? And I think if you keep some principles in mind, this will really help you out. For one thing, if you can think of the layers all the time and think about what layer is the problem. So for example, if you've got your cable connected and you've tested your cable, you know it works, well, you can rule out layer 1. Like you've tried the cable somewhere else, you know it works, so rule out layer 1. If a link light is popping up on both devices, you can rule out layer 2 and start troubleshooting layer 3. In fact, that's where it gets more interesting. If you're having trouble getting to a particular device, being able to map out the network diagram either in your head or if it's complicated on a whiteboard really helps in the troubleshooting process. And then think in terms of protocols. Which protocols are working, which protocols are not working. So this is just the scientific method. It's a process of narrowing down, ruling out what it's not until you figure out what the problem is. Ping is the number one thing you're going to use as a network engineer. Pinging means happiness. If you can ping something, you get a reply. That's great. And it helps you kind of target how far out the network you can get. So can I ping myself? Yes. Can I ping the management interface of the switch? Yes. It means the switch is online. Now, yes, a switch works at layer 2, but the management interface is going to have a layer 3 IP address because you're paying more for a managed switch, right? Can I ping the next level out to the router interface, the inside interface? Can I ping that? Can I ping the outside interface? Okay, can I get one router hop outside of the network? Can I ping that? Where's the breakdown happening? And then I've got this tip of a laptop is your friend just because you can plug it in anywhere. If you want to simulate being outside your network, well, all you do is plug into a switch that's outside your firewall, and you can simulate being outside the network even though you're not physically, going home to test something out or going to another location to test something out. So laptops are handy. And let's see. TIMS 3Rs. This is really more for PC support, but it's somewhat related to networking. TIMS 3Rs are, when in doubt, reboot. If that doesn't work, reinstall the application. And if that doesn't work, rebuild, which means to reimage a PC. There's no glory, there's no elegance to this system. This is just something that I've developed over the years for efficiency. At the end of the day, you almost don't care what the problem was if you can get a customer back up and running quickly. If rebooting doesn't work, just try reinstalling the application instead of troubleshooting and looking in the registry to see what went wrong and looking in the event viewer and saying what went wrong. And if you spend more than 30 minutes, just reimage it. Just take a semantic ghost image or whatever, or a Cronus, true image, whatever you're using to image out all your PCs. And if this is unfamiliar language for you, this is how PC people do what they do. So rather than spending days rebuilding a PC, it's a process that just takes 10 minutes now. Just slap a new image on a PC and you're back up and running. The customer's happy. Well, similarly, in networking, WIDR, when in doubt, reboot. It's very common for network engineers too. If there's a piece of equipment that's not doing right, just bounce the router. Just reboot it and see if that fixes it. Now, be sensitive that you're breaking the connection for everybody in your company if you do this. So be sensitive about the time of day you do it. Or you can just blame the telephone company, which is what we all do when there's an outage. And finally, the most important acronym is RTFM. Read the manual. Read the freaking manual, said the senior network engineer to the junior network engineer. The reason I say this can be a great interview question, for one thing, if somebody asks you, how do you troubleshoot issues, you can kind of jokingly refer to the 3 R's or when in doubt, reboot. Hiring managers also want to hear of a time when you had to troubleshoot something and you had to figure it out yourself by looking it up yourself, doing your own research. Anybody can walk over to the senior network engineer and say, hey, how do I fix this? Right? That's the easy way out. You get a lot more street cred if you can figure it out yourself, right? And so managers are looking for go-getters. And a way you demonstrate that you're a go-getter is you're willing to crack a book, you're willing to Google a problem, look it up on the internet, look through some networking forums, and figure it out on your own. I think that's what makes a good network engineer. Just some final language stuff. Turn it off and back on again uses 8 words, so we don't say that. Shut it down and restart is 6 syllables. Sorry, 8 syllables. 6 syllables. This is a joke slide. It's funnier if they're kind of flying onto the screen, one bullet after another. Power cycling is 5 syllables. Rebooted is down to 3 syllables. But we've perfected our minimalism in linguistic effectiveness down to 2 syllables, which is bounce it. Bounce the router, bounce the switch, bounce the PC, bounce the server. When in doubt, that's what we're doing. These last 3 slides is really something we have to do in class. These are 3 scenarios, but I want you, it would help you out just to think through these 3 scenarios that I've come up with to see how you would go through troubleshooting it. And not just what the right answer is, but what's the process that you go through to troubleshoot. That's what separates a good network engineer from a great network engineer. It's just the ability to think through something critically, analytically, whether you're thinking through the layers, whether you're thinking about protocols, whether you're thinking about a network diagram, that you have some systematic way of thinking. Those are the critical thinking skills that are the holy grail for hiring managers. So that's why I spend so much time talking about it. With that, I'm going to wrap up Chapter 9, and I will see you in class next week. Thanks.